Imagine not using AI in the Lord's year 2025. I know what I did wrong. Dang it. What am I doing wrong here? I think I see the problem. I think it's pretty obvious here. I've misread it like a dum-dum. No! Okay, well, that's still incorrect. I don't know what's actually happening here. Whatever. Stupid. Who wrote this? People that are watching this video are gonna think that I'm a weirdo.
Okay, why would you ever want to build an HTTP server from scratch? And I mean like from TCP scratch, not like, oh, I used the Golang HTTP library. No. No libraries, no frameworks, hand-rolling HTTP from TCP. Look, I know Apache and Nginx have both been around for like 20 years, but this course, and specifically the parser
done,
that we're going to build in this course, is one of the best exercises for newer developers. It'll help get you to that next level. The Primeagen, who wrote this course and recorded this walkthrough, said,
I feel like this is a great way to go from like a junior engineer into a mid-level engineer.
But before I dump you right into all the string parsing glory that is this course, let me give you just a bit of a teaser of what's going on here, considering it is like, I don't know, 5 hours long or something, which is impressive because Prime actually streamed this walkthrough in a single day, and he only had to take a break to use the bathroom like 17 times.
All right, hold on, I gotta go pee. All right, I gotta be right back, I gotta go pee.
So we're learning all about the HTTP protocol in this course, and we're doing it by building an HTTP parser and server from scratch in the Go programming language. That means we will not be using the built-in HTTP library at all. We'll be building our own. Though of course we will be using the TCP library, which is just the protocol that HTTP is built on top of. So we're gonna start off exactly the way you should start learning a network protocol. And that's by not using a network at all. Prime's gonna teach you how data is streamed from a file into your program through the exact same interface that it's streamed from a network connection into your program. Then he's gonna cover TCP.
Now we're gonna move into TCP land, okay?
And contrast it to UDP and how HTTP is built on TCP, and that's why it makes a lot of the assumptions that it does. Then he'll cover the structure of HTTP requests, breaking down the request line, the header, the body, but he's not just going to explain all this stuff. Again, he's going to build the parsing logic and server from scratch with you. Our server is gonna be able to read from a connection byte by byte in real time. Anyways, then we'll move on to HTTP responses and even get into some of the more advanced stuff you can do with HTTP, like chunked encoding and binary data. We'll even serve an entire MP4 video directly over our TCP connection. So there's a lot of really cool stuff in this course. Now, I do not recommend sitting down and binging this course all in one sitting. Actually get your hands on the keyboard and follow along. Make an account on BootDev, it's free, and actually go ahead of Prime and watch him go through the same lesson that you just went through so that you can see his approach, his commentary, and his solutions only after you've had a chance to practice and experiment and challenge yourself. As you know, all the content in this YouTube video obviously is free, but also all the content on BootDev is totally free, at least to read and watch. That said, all the interactive features on BootDev are paid. So if you want to be able to submit your own assignments, if you want to view solutions, chat with boots, get a certificate of completion, that kind of stuff, you will need a membership. And if you want to get one, just use Primeagen's code PRIME to get 25% off your first year if you choose an annual plan. And part of that payment will also go directly to supporting the Primeagen and help him and his content. One last note, the only reason we can put our time and resources into creating these types of courses is due to your support. So please like and subscribe to our channel here on YouTube. It just takes a second and allows us to produce more and more of these long form video courses and release them for free. So really, thanks for doing that. Now, let's go write some Go code with the Primeagen.
Are you ready for the full ass course going on here? So here we go. I'm gonna skip all the additional reading because, you know, if you want to take the course, it's open, which by the way, you can take it without all the interactive parts and it just works. Just so you know, you can take it without any of the interactive parts and it works. So right, like I'm not gonna read the introduction. There's nothing here other than like fun stories that I tell. You know, there's a little fun story about like me the first time I got Shazammed, the first time I got one-shotted. I got one-shotted hard in college. This is why I'm a programmer, okay? I got one-shotted twice. Once by a linked list and once by the social network. It's that simple. Welcome to the startup. There's a few days in your life more magical than your first day at the startup. My best days in order have been my first day at the startup, my wedding day, and birth of my first child. Here at the startup, your first task is to build an HTTP server from scratch. A multi-billion-dollar exec hangs in the balance. Before you begin, the startup has to finalize your hiring first. We will screen all of our newbies by asking them to build a much simpler protocol first. We'll start with reading text from a file and printing it to the console. Look at that. Boop, boop. All right, here's the text. So create a new project. There we go. Create a messages.txt. Let's do this, baby boys. Messages.txt. Let's go. Put that in. Put it in. Create a Go module. All right, Go mod init boot.theprimogen.tv. Let's go. Create a main.go. At the root, simply for now, print out this string. I got the job. Okay, I got you, baby boy. Baby boy, I got you. I got you. PV main.go. Let's go. Package main, func main, do one of those. Let's see, format, print ln, there we go. And print in that thing, there we go, boom. And let's do that. There we go. All right, we're looking good. I think I've won. All right. I'm not even gonna try, dude, first try. First try, dude, we need a first try counter right now. Here we go. All right, how many first tries am I gonna get? There's my first try counter. All right, there we go. We're currently at 1. Do we get 2? React is my language? Okay, well, that's unique that you have a language. I didn't realize that libraries could be languages. And boom, got another one. All right, we're going up, boys. Boys, we are going up. Okay, you can F this up so easily, right? Like eating 8 bites at a time. Eating 8 bites at a time, really easy to screw that up. Here we go. Okay, we're gonna remove this printing. Instead, program will now read messages.txt 8 bytes at a time and print out the data. Okay, true. We're gonna do a little bit of an open. We're gonna do a little bit of a while there's still data in there. We're gonna read 8 bytes at a time. We're gonna print it out with read : that. Okay, when you hit an end of file, error, exit the program. I got this. I got this, boys. Equals. Oh, we got that. Dude, hold on. Hey, for you guys, just so you can't be like, you're cheating. Super Maven. I will stop the Super Maven, which, by the way, you should not use an autocomplete or AI when you're learning. Okay? Because if you do that, you're just like, honestly, you're going to be a sad panda. I'm just letting you know. You will be a sad panda if you do that. Wait, what? Which one do I have for, okay, I thought EL did that one. Okay, whatever. There we go. We'll just do that one. We'll do that one. There we go. Little log fatal. We'll get in there, and we're going to go for data equals make byte 8. There we go. We're going to just read out this data, boys, okay? Equals, what is it? It's f.read, there we go. Data, yeah. I'm a little bit elixir pilled right now, so I'm like, okay, which one do I do? Which one do I do here? Data equals data. Oh, I don't even have to do that. Format dot print ln read. Actually, no, I have to do f me. Data string n. There we go. Boom. I know it says do an end of file, but look at me, I'm not even doing an end of file. I'm just doing it to here, okay? Because I'm a rebel. I'm an effing rebel, okay? There we go. All right, anyways, let's keep on going. So I think I got this right. Let's just go like this. There we go. Brother, got another first try up on the list. Let's go. Another first try. I knew I was the best. Okay, there's a reason why I wanted to go through this exercise, and I think it's really, really good for anyone who's ever building their first protocol, because I think understanding reading from a file makes perfect sense. And so right now, just to kind of put us all on the same page, what are we doing right now? Well, what we're doing right now is that we know that we have a file that's filled with a bunch of data, right? And we are going to take that data 8 bytes at a time and just keep on reading it 8 at a time. Like, this is a very, like, you get this, right? It's literally just a contiguous block of things that you read. Okay, so now that we all understand that, you can see that this is working, which is really good. Reading 8 bytes at a time is a good start, but 8-byte chunks aren't how people tend to communicate. You probably have noticed that it was hard to read individual messages through your program. Trust me, this all needs HTTP, I promise. Yes, I know. I intentionally made it this way for a reason. Let's update our code to continue to read 8 bytes at a time, but now let's format the output. %s represents an entire line. Okay, so now we're going to read 1 line at a time. All right, so this isn't too hard. By the way, I'm going to write really shitty code. So just everyone be ready. Like, this isn't meant to be very beautiful, okay? Look at that. I'm doing that. This is not performant. This is not beautiful. There's nothing about that. That's fantastic. We're just going to crush some butt. Okay, everybody? All right, good. I want everyone on the same page. So I'll just go like this. Bytes.index.newline. Wait, I think there's index byte, right? Yeah, index byte. So I can go data. There we go. Data, let's see. Data equals data, and there we go. We'll do a little slice. So we have those things. So we have this little bad boy right here. If I equals that, we'll do that. I is does not equal 0, right? There we go. So if we found an index, we will simply go stir plus equals string, let's see, string data up to I. Yeah. And then we'll go data equals data starting from I. Right, starting at I plus 1 because we don't want that new line. Very, very simple. There we go. And then I'll go print format. There we go. Print. We'll print all of this stuff up to, we'll do string, and then we'll go stir equals that. Now this, again, this is not great code. But remember, we're not trying to write great code. We're just trying to write code. Okay, so there we go. We'll do this bad boy. Else we're going to go like this, string plus equals a string, and then we're going to go data. We're just going to go data, right? We're just stringing up the data, boys. We're just stringing up the data. And if we have anything left over, wrong language, then we'll just hit it up with one more print. There we go, and that's that, right? So if I've done this correctly, let's go run. Ooh, do I even want to run this? Okay, since we're trying to one-shot everything, let's look at this. Reading 8 at a time. We are slicing things out. We're seeing if there's a new line. We're adding it to the string. We're doing a little bit of that. We're doing that. We're resetting the string. We're adding the rest of the data. Yeah, I think we could one-shot this one. We're going to one-shot this bad boy. We're going to one-shot this bad boy. And we didn't one-shot this bad boy. What happened? Who did this? I'm a fraud. I'm a fraud. Go run main.go. What did I do wrong here? So why is this slice out of range? On 26? Really? What did I do here? Wait. Oh, does not equal 0. You idiot. It's -1. Oh, my gosh. If you wrote code like mine, there's a good chance you've got a little state machine going on directly inside your main function, which we kind of do, right? It's like a little state machine. This is why you quit Netflix. Shut up. Create a new function called getLineSignature. Boom. We're going to copy this bad boy out, and let's create this. Let's go up here. We're going to paste that bad boy in. Hopefully everyone sees where this is going because this is getting awesome. It's about to be awesome. Notice that we're using a read closer here. For those that aren't familiar with a read closer is just a reader and a closer. If you're not familiar with a reader just simply has that one function on there. A closer simply has this one function on there. That's all it is. It's just an interface with read and close. That is it. Nothing else. Okay, out makes, chan string. Let's go 1. We don't need a lot, right? Return out. Func. By the way, this is how I can always tell someone's using ChatGPT, is when they write something like this, and then they just start onto their next thing. I'm like, nah, I think you're lying to me. I think you're lying to me because I feel like you would do the return because this is like out of band. You know, people write really linearly. Like when someone writes a function from top to bottom and one-shots it, I'm just like, you're a cheater. You, my friend, are a cheater. Okay, so we're gonna do a little defer. So we need to close our channel, right? Because if you don't close your channel, things, are stupid. And then we're gonna go f.close as well. Right, so there we go. We have our 2 closes. And so now all we have to do is just reread this nonsense right here. Take that, yank that bad boy out, put it in here. Let's just do a little equal sign there. And then we also need to go down here, yank one of these. And I know I wrote this all crappy, but hey, deal with it. And let's go like this. Okay, and then let's go lines equals, what did we call it? We called it get lines from channel. That's not a good name, by the way. It should be get lines from reader, but hey, this is where we're at in life. Okay, this is where we're at in life. Arrange lines. And then we need to do a little printing. So right here, I'm gonna just take all these things and I'm just gonna replace the printing with the string that I was gonna originally send out, right? There we go. Easy peasy lemon squeezy. And then format print F, and then I think I still need to read that. There we go. So if I've done this all correctly, there we go. And let's see. Let's just make sure I understand the assignment here. Create a new function with the signature. Yep. It creates a channel of strings. It does the reading inside the go routine. Got it. It does not prefix. Yep, I got that. All right, perfect, perfect, perfect. And then we do this. Update your code to use a file implements read closer. Yeah, prefix everything with that. Okay, perfect. One shot, boys. Boys, we are one shot in this one, and we one-shotted it. Let's go. We're going on. So this is where things get a little bit magic, okay? We're getting into the magic side of things. Because notice what we've done right now is we've used a file, we've read a file, then we just moved it up into a function, and then we used Go channels to send out the information. There we go. This is where I'm at, right? There we go. Why are we reading files? Because this is the best way to understand other things. Now we're gonna move into TCP land, okay? All right, so what we're gonna do here is we are gonna send some data over the wire. By the way, Lane had to make this change because he was totally wrong on some stuff. We're gonna send some data over the wire instead, right? And so what we need to do is we're gonna remove all the logic that reads from a file, and instead we're gonna use net.listen, okay? And we're gonna set up a TCP. And then we gotta call accept, and then we're going to use the same function, get lines from channel, and then we're going to print all the messages. Okay, so that means we're going to go like this. So instead of doing this, which opens up a file, right? Watch this. So I'm going to go like this. Get from file, right? So I could do something like that and get this from a file, but we're just going to close it. Don't worry about that, right? So I'll go like this. I'll go listener, right? And then we're going to go net dot, what is this? What is it called? Listen, right? And I can go TCP, and then I can go 420.69, there we go. And then I can do check on this guy, awesome. And then we can do a nice little for loop right here. And instead of doing that, we're gonna go like this, con error listener, listener dot accept. Accept is just like it is in Berkeley sockets effectively. This looks like mostly like a Berkeley sockets thing. So now we're gonna create a server. It's gonna get TCP connections coming in, and we're gonna get this connection, and we're gonna get this error, okay? Very, very simple. And from there, I'll do the exact same thing. We'll go 6 up, 6 down, bam, bam. There we go, do one of those, and then I'm gonna go like this. Instead of doing, or now I just do one of these, I'm gonna go like this, line equals, and then I can range over, get line from channel, and I can just pass in a con. Now notice what we did right here. It's literally the same code that we had before, right? Nothing changed. So this is why I wanted to start with the file, and I think this is just really, really great for somebody looking at this for the first time. But you'll notice that I didn't change anything to do with how I'm reading data out. The only difference here is that instead of passing in a file, I'm passing in a connection. Because really, they're the same thing. You can read 8 bytes at a time from a connection. You can read 8 bytes at a time from a file, right? It's the same principle, right? Does that make sense? I think a lot of people don't make that connection, that it's really, really, really simple, that it's just a reader. It's not just that it's a reader, right? That's like a goism. If you think about it, a file represents some contiguous piece of binary data, right? How you interpret it is, you know, whether it's ASCII or not, whether it actually has meaning or not, doesn't really matter. But a file itself is just a contiguous set of data. An internet connection that you get from somewhere else, it's just the exact same thing. It represents a contiguous stream of data. The only difference is that when you're working with the file, you get to determine how much you read from the file. A connection, on the other hand, it pushes data towards you. You pull data from a file, you get pushed data from an internet connection, but the interface is the same. And so that's kind of like this kind of magic thing that I think a lot of people, that it makes writing internet protocols seem a lot simpler once you realize that you're just simply working with ordered data, and that's it. And once you understand it's just ordered data, it's no different than reading from a file, you go, I get it. It's just a stream of bytes and it's in order. That's what makes TCP good. Oh, the push and the pull is really helpful. Yes, it's really, really helpful, right? It's really, really helpful for people to do that. Let's keep on going. So, okay, let's see what we have to do here to make sure this all works. Okay, all right, let's see. You can terminate the program by using Control-C. You can run the server again and T the output, copies the standard out to a new temporary file. Okay, we can do that one. Let's see. Run and submit the CLI test while the server is running. Sure, we can do that. So I'll go like this. I'll run this thing. So there we go. We have it running. And then I'll grab this thing, and let's do this, and we just got brother, we just got ourselves another first try. Let's go. Uncompiled, untested, First try. Let's do this. Even while telling a story about a horse. All right, let's see. We run and submit this. We did this all. We haven't shipped a way to customize the port on the CLI command. They did, apparently, yes. Admittedly, Prime's probably the only person that might have conflicts on port 42069. I did. I actually had to turn off my voice stuff, like our little TTS AI thing, and I had to change its port to 42068 because, yes, admittedly, I'm the only person that's default first port is 42069. Okay, this is a very important port to me. All my programs do that. So what is a protocol? To put it simply, a protocol is simply a design or a spec for one computer or device to communicate to another. It describes how you break down the data, how exactly it is formulated, the header packets and all that, so that the other side can reconstruct messages sent across the wire. So why does HTTP1 use TCP? Well, TCP is reliable in-order packets. Let's do a little example here. Let's say I needed to send it off something that contained 8 packets in it from one computer to another. Now, how this would normally be done with TCP is I would have something called a sliding window that will contain how many packets we can have out in flight at one time. Let's pretend we had a sliding window of 4. That means I can send out packets 1 through 4 to the destination computer. So 1 would go across. When 1 gets over, the receiver needs to send an acknowledgement. The acknowledgement will come back at some point, and when received, our sliding window can proceed and send this out. While we're waiting for that one acknowledgement, we can send the other packets out that are within our sliding window. This allows us to send a bunch of data at once, not just sending one simple packet at a time. This is how TCP is in order and reliable. Every packet that is broke down for a big piece of data is broken down to individual packets with IDs, shall we say, and a destination, which port it needs to go to, and then it will properly be routed to its address, and the receiver will be able to reconstruct the data in order. And obviously packet ordering makes perfect sense why it's important. If you were to send, say, a JSON object across the wire, remember, that's just text, right? That's just simply bytes. We can send that across the wire. But what happened if you got it out of order? Well, you wouldn't be able to use JSON parse. It would explode. You would get an exception in JavaScript. Now, you've probably heard of something called UDP, which is a little bit different than TCP. But generally speaking, UDP is considered more performant because it does not wait for an ACK. But here's the deal about UDP. With TCP, you send across your entire JSON blob. But with UDP, you have to make the decision how you're going to break up all of your data, how you're going to organize it, how to reconstruct it on the receiving end, and then how does the receiving end know that it's missing a packet? And so this is very, very important. So let's just pretend this again. We're going to send all 8 pieces of data at once, just bam, 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 bam. We have to come up with a strategy to know if the receiver hasn't received a data. Maybe it didn't receive packet 6, so the receiver is going to send a NAC, a negative acknowledgement, and say, hey, you know what? I didn't get this one. I seem to get everything else, but I didn't get that one. Now, it still may be in flight. It still may come. So you'll have to come up with an algorithm that can receive 2 of the same packets. You're going to have a lot more protection in it that you don't even have to consider when using TCP. But you can see why this is more performant. There is no acknowledgements. And right now, a pretty good packet loss rate is less than 1%. So let's pretend for a second that it is 1%. That means you're only losing 1 packet out of 100. That means you are not waiting for acknowledgements 99% of the time. And that one time it does happen, you do end up getting a NAC, which means you have to be able to hold the data on your server long enough to be able to negatively fulfill requests that you've sent with UDP. Yes, okay, so we're talking a little bit about TCP versus UDP here. This is just simply going to go over a little bit to do with UDP, which is perfectly fine, a lot of fun. So a lot of good jokes. Everyone has a bunch of jokes. Like I could tell you a joke about UDP, but you probably wouldn't get it. UDP is a stateless connection. In other words, you don't actually make a connection. You don't do a handshake. You don't say, hey, I'm going to send you data. Then it goes, okay, you can send me data. Then you're like, okay, I'm going to send you packet 1. And it's like, hey, I got packet 1. And then you're like, okay, I'll send you packet 2. And you're like, hey, I got packet 2. Right? That's what TCP does. UDP, you're just like, hey, hey. And if there's nobody listening, it's like, hey. And that's all that happens. You don't even know, right? So there you go. We got all these things. So this is awesome. So that's one thing that makes TCP so great is it's in order data. So what is the requirement here? Move your main.go file into command TCP listener. So I'm just going to go like this. Make dir-p command TCP listener. There we go. Move main.go into command TCP listener. Boom. Let's go. All right. We did that one. Done. Run your TCP listener with this one right here. Okay. Nice. In a separate terminal, do this one. There we go. You should see a connection accepted message. Okay. Yep, there we go. We got it. We now have that thing open. Okay, cool. Kill both programs. I'll run this again, and let's see. You should see the. Yep. Okay, there we go. And so if I do that one, connection refused. Okay, good. We've seen all these things. Awesome, awesome, awesome. That's because TCP requires a connection. Yes, 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 yes. All right, we're gonna do this thing. Bam. And we're going to throw that in there, and then we're going to go in here, and then we're going to go up to here. I'm going to yank that bad boy. We're going to paste that in, and boom. We got a first try, boys. We got a first try. We are first trying again. All right, babies. All right, here we go. 6. We are cruising, okay? UDP is a lazy job's worth. UDP is actually fantastic. UDP is objectively the better internet protocol, but only during a day and age in which the internet is reliable. All right, so this one is a very simple one in which we just simply create a UDP version and we rerun this exact same thing, but we just show with UDP instead of TCP. So it's the exact same thing. What's true of UDP? It guarantees packets arrival in order? No. It establishes a persistent connection? No. It doesn't require a handshake? Yes. Bam. So remember that when it comes to UDP or TCP, both of those are just simply protocols. They don't actually have any sort of meaning beyond, like, can you inject a security into however you implement a security issue into however you implement your UDP strategy versus your TCP strategy. So yes, like theoretically, one could argue that UDP has a greater danger because maybe TCP is so well tested and so old versus UDP. Maybe some people are doing some new fancy things with UDP that accidentally, say, introduce some sort of denial of service attack. So maybe one could make that argument, but I just don't think that you should. That's not a good argument. Can you encrypt UDP? Of course you can encrypt UDP. It's just that the encryption is a bit weird in the sense that, remember, UDP is just datagram packets, meaning that you get a packet and that is it. So you have to have you have to provide all of the additional fun stuff. You have to, it's a little bit harder. That's what makes Quick, which is TCP/3. So there's no TLS for UDP. It's not the same, right? Because there's not structured in order data. It's a little bit more tricksy. Isn't Quick more secure than HTTP over TCP? No, Quick is just how you frame HTTP. It's just simply UDP. It's TCP over UDP. The problem is that you have packets that you have to encrypt the data differently, right? It's not as easy because in TCP land, you have ways in which you can specify structured data. So TCP will send all this data in order. UDP doesn't. You have to do the ordering yourself. Effectively, you put a TCP header into your UDP, and then you could probably do some sort of encryption. You just have to let the things know. You need to let them know where the boundaries are. You have to do the same amount of work. It just looks differently because now you're going like this. So usually what will end up happening is that in your standard networking, you have your TCP layer that structures the data. You have your your layer that does the security, the decryption of it, and then you have your application that gets the data that has been decrypted and all that beautiful stuff. Well, in UDP land, it's kind of like you get all these UDPs, then you have your framing protocol figure out what needs to be decrypted, and then you have to go back to this. It's a little bit weirder, but that's about it. There's some weird oddities when it comes to UDPing versus TCPing just due to that. Did Netflix have it? Yes, Netflix did have its own version of TCP over UDP. There is a protocol for TLS over UDP. Yeah, DTLS. Yes, there is, but it's just I'm just saying it's a little bit more complicated because UDP doesn't have structure in of itself. You have to do this weird dance that's just unusual comparatively to TCP. TCP just can do things that you can't do with UDP. Or it's not as simple. It's not as easy to think about. What do you mean TCP over UDP? Remember, TCP is a packet ordering protocol. UDP is just a packet protocol. So now you have to add ordering to UDP. You can add ordering and reliability to UDP by implementing TCP. The IO reader and writer interfaces in Go are useful for reading and writing data, to and from network connections, files, both. Well, really, it's to anything. It doesn't even have to be both. It could be all sorts of things, which pushes data to the application that's reading from it, resulting in a reader needing to be prepared to read data. So when you're pushing data, that means it's coming from some sort of external source. You cannot control the timing of it. That would be a network connection, right? So you're probably asking yourself, why do we use HTTP and not TCP? Well, it actually is a pretty simple answer. TCP guarantees that your data is in order and complete, that there's no missing packets, that there's not problems. but it doesn't really tell you what the data is. Am I sending you just JSON? Am I sending you some sort of image? What am I actually sending you? HTTP gives you the ability to specify what you are sending. So first off, it also gives you a destination within a server, because just because you're on a port and an IP address doesn't mean it's going to the right place still. So first off, HTTP comes with kind of like your main address, like, hey, I want to go to /cats and I want to get all the images from /cats. Next, it's going to have some basic kind of control things. We call these headers or field lines from the RFC. After that, we're going to have a body if you need a body. Most requests don't come with bodies. Usually it's the response from the server that comes with the body, and the body is usually the data you are requesting. So without HTTP, our TCP data would effectively be meaningless. How do you ever even parse it or come to the conclusion for what I am requesting? And during this whole course, we're going to be talking about HTTP 1.1. But the reality is we're not just talking about HTTP 1.1. RFC 9110 actually contains the semantics for all of HTTP. We're going to be primarily using 9110 and 9112 for implementing HTTP 1.1. And the reason being is that HTTP 1, 2, and 3 semantically are equivalent. It's just simply the implementation across the wire that is different. So in HTTP 1.1, we still send headers, but we send the same headers every time. Potentially you're sending really large cookies, or maybe you're sending all those different things that are all the same every single request. With HTTP 2 and 3, there's something called HPAC and QPAC, which allow you to take the same reoccurring headers and actually shrink them down to, say, a couple bytes. This could be beneficial considering how big some of these headers can get. Now, the shape of any HTTP message is going to be the same whether it's a response or a request. There's just some subtle differences. Effectively, everything is called an HTTP message. Now, an HTTP message, the first line is going to be kind of the declaration. So say on a request, it's going to start off with a big capital letter get. This is going to be a get request. The next thing is going to be the destination. So it could be get cats. And lastly, it's going to be the semantic version of HTTP. So it could be HTTP 1.1. Every single line in the HTTP 1.1 algorithm is separated by a /r/n, which I jokingly refer to as a registered nurse because that's the only way I can remember the ordering of /r then /n. So after the first line, the status line, we then go to the field lines. Now there can be 0 or more field lines. Field lines are headers. Simply it consists of a field name, a colon, and a field value, and then one registered nurse at the end. And how HTTP 1.1 knows it's done is that there's an empty field line. It's just simply one registered nurse and nothing else on the line. After that, it's just the body. Now, you're probably asking yourself, well, how big is the body? There's a couple different strategies. There's chunked transfer, and then there's also content length. You've probably seen content length a few times if you've ever been perusing request and response. The content length will tell you how big the body is in bytes. During the course, I'm going to be referencing the RFCs 9110 and 9112 quite a bit, so if you take a look at those, it's actually pretty helpful, especially 9110. It's a very long document, and it could take quite a few hours to go through, but it would definitely shed a lot of light on why things are the way they are. So let's get into the HTTP world. Are you guys ready for the HTTP world? But if you're still implementing TCP on top of another protocol, wouldn't it be slower? No. It's a common misconception. What makes TCP slow? Remember that there's like this whole sliding window thing that goes on. Don't worry about all the requirements, but TCP, there's a lot of back and forths to how you send data, right? Then you send a bunch of data. This represents the handshake, by the way. Then I will send, say, 3 pieces of data because my window, say, is 3. And I have to get messages back for each one of these pieces of data, right? And until I get back, say, this one, I can't send the next one. So if I get back, let's say this one fails, but these 2 pass, I can't move my window forward until I get this one successed because my window is only of size 3 and I'm kind of trapped on this one packet. Now with TCP over UDP, we don't have to acknowledge every single packet. Instead, we can negative acknowledge packets, meaning we didn't get that packet, meaning we could actually go much, much longer. We can send much less packets back. We don't have to wait. You can just send all the packets you want. And I'm like, yeah, man, I just missed one. Here you go. Hey, can you please resend this one packet to me? I got everything else. So that's why TCP over UDP actually tends to be a lot faster, or one of the many reasons, because you don't have to have this whole like sliding window slow thing. You can just spam it and you can just receive it, right? I don't have to be like, hey, I got 1, hey, I got 2, hey, I got 3, hey, I got 4, hey, I got 5, right? You don't have to go through like that whole thing. You can do other things. The missile knows where it is because it knows where it isn't. Exactly, that's UDP. There's like a lot of things you can do that you can't do just with TCP. Yeah, there's a huge yes, because you're just doing less. People don't realize how much less you can do with UDP. And the reason why this is all possible is because networks are so reliable today. UDP wasn't the default because 30, 40 years ago, networks weren't as reliable. When you have like a 20% drop rate, it becomes much, much harder to implement protocols that follow constantly, right? All right, let's keep on going because we got a lot of stuff to do. HTTP works because plain text is binary, because HTTP uses TCP. If the HTTP request or response is too big to fit into a single TCP packet, it can be broken up into many packets and reconstructed in the correct order on the other side. TCP guarantees that data is in order and complete. I've already talked about that. At the heart of HTTP is the HTTP message. So if you haven't been inside the protocol, I'll be referencing a lot of stuff from the RFC in this course. The RFC is giant. Okay, RFC 9110 and 9112 represent HTTP 1.1, or a good part of it. 9110 is like the semantics of HTTP, which means that it applies for HTTP 1.1, 2, and 3, which is quick. But HTTP 9112 is just HTTP 1.1. And so we're going to really be just focusing on that because it's really easy to understand. And if you understand HTTP 1.1, you technically understand HTTP 3. You just may not understand the actual protocol representation of it. So that's kind of why it's okay to start at 1.1, because you get the picture. So there we go. So here is what HTTP 1.1 looks like. It has a start line, then it has a CRLF, which I like to call it a registered nurse, a /r/n. It's much easier for me to remember that way. A field lines. These are headers. Field lines are headers. They just use the term field line in the RFC. They don't, field name and a field value. I know, we call them headers. And then we have a message body, which is optional. Okay, fantastic. You can see right here, bada bing, bada boom. All right, so what is our assignment? Our assignment is run your TCP listener program to redirect the output into a temporary file. Shazam. Got it. Okay. In another shell, do this. All right, perfect. There we go. There we go. We got those two things done. Kill both programs, and then do this. Deal. We're first trying, boys. We are first trying so hard. So dang hard. To be clear, the startup will build HTTP 1.1. Up-to-date technologies at a serious software org. Impossible, right? All right, so there you go. There's all the stuff I talked about with the RFC, right? There's 7231 is like the active reference that people tend to use. Here's the other two that are really good. This is the old HTTP. There's a lot of RFCs for HTTP 1.1. So don't get confused. We are going to be referencing the newest one that's more broken up and I think easier to understand. All right, which RFCs will we be referencing on this course? The Primogens. Dang. Wrong. Okay, we'll be doing this one. So probably have already figured out, curl is a command line tool for making HTTP requests. If you cat, this will be what is created. This is basic HTTP right here. Nothing to it. Very, very simple. This is a raw HTTP message looks like, specifically the original one. So now if you remember this, here is the start line. Here are the fields. Here is the empty. You can't really see it, but here's the empty header. Apparently, they didn't have the empty header in here. Here, let's go like this. Temp, what's it called? HTTP. No, it was raw, right? It was raw get HTTP. There we go. You'll notice that there's an extra additional line right here. That's because for HTTP to work, there's that extra empty header in between the message body and the headers. That's how you signify that we're going into body parsing. And since there's no content length, there's nothing that says that there's a header here. There's no chunked encoding. We know there's no message body. Right? Typically, that's how you do that. All right. That's at least how all HTTP 1 has kind of done things, is you need a content length or a chunked encoding. Transfer chunked or whatever it is. I forget the exact name for it, honestly. It's been long enough that I forget the little details. Okay. So let's see what a raw post looks like. Yeah, let's post it up, boys. All right, there we go. We have the post, so now I'm just going to curl, but let's grab the curl post right here. Bam. Awesome. There we go. That should get everything in there. Awesome. Now we should be able to do that one. We should be able to grab the submit. Put it in there, and we passed it again. Oh, boys, we are just first trying like a boss. Okay? All right, you probably already figured this out or knew, but curl is a command to line up. We've already talked about that one. There you go. So I put this out in a more obvious way to look at it, which is a get. We have a start line. We have our field lines. We have our empty field line. We have an empty message body. For a post, though, we have our start line. We have our field lines. Notice that we have a content length 22. That's this right here. That's 22 right there. It says it right there. We even say the content type, which is JSON, so that helps. Like, that's why whenever you use a server and automatically an object comes out, it's because the convenience is from the header telling the protocol or telling the server that what comes through is JSON, and it can take the liberty of already doing that for you. If you've ever worked with something that adds a little extra convenience to it. That's also why your client, when you receive an image or if you receive JavaScript and it has application text, it will fail to load often. It's because you have to tell it that it's loading JavaScript for your browser to be like, it's a safe resource to execute JavaScript with. Which of the two requests has a message body? That'd be a post. Gets typically don't have bodies associated with them, but you can. You can technically do any of it you want. You probably already figured this out, but curl is a command line tool, blah, 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 blah. Which line is not a field line? Field line, not a field line. That's the start line. Boom. In most of our Go courses, we encourage the use of standard library testing packages and tend to use table-driven tests. But the PrimeGen X Netflix, by the way, yes, X Netflix, because I quit, has a different preferred approach. So we'll roll with that in this course. Yes, it's true. So this is typically how people write apparently tests. Is this? Now me, I do not like table-driven tests. I think these are an abomination. And the reason why they're an abomination is that I do not like adding logic ever. I want my test to be as declarative as possible. So this is how I prefer things when it comes to tests. I want things so dead simple that I never, ever, ever have the possibility that I get misinterpreted, right? Like that I can somehow goof stuff up. I don't want to have to, like, I hate debugging table tests. I hate having to set breakpoints or print effing through a bunch of not needed ones or adding if statements around tests. I want them to be simple. I want to turn on or off things much easier. I do not like table tests. I have never been a table test guy. That's it. I actually hate tests. Well, okay, that's fine. When it comes to doing something like HTTP, you should probably have tests. The reason why I say you should have tests is I have a very simple rule, which I think I put it in here, and I tell people why I do. There you go. So I try to make my tests big, just generally speaking. The more things I can cover, the easier it is to, like, underneath move things around without the test breaking, right? I think everybody gets that. End-to-end tests will probably break less than unit tests. Pretty reasonable, right? But I rarely write tests. I only write tests for functions I don't think I can get right first try. So if you ask me to sum an array, I'm not going to write a test for it. I already know I can do that. I can do that every single time. I'm not worried about it. It's just not something I think that there's going to be a high probability for a bug. If it comes to text parsing, okay, easy to screw up. There's some cases that I may not have thought about. It's a little bit nicer to have tests for. So I kind of have this, I have that as my mentality. Okay, there we go. So here we go. I prefer the simple procedural approach. Yes, I like this. Fewer conditions, fewer things for me to get wrong in my tests. Correct. Because I don't like logic. Okay, logic is where bugs are at. Last thing I need to do is have tests for my tests. We'll be working with a request line parser, so let's get our directory structure and test dependency set up. So Lane has changed my directory structure, and that's okay. We're having internal requests. All right, we can do this. I can roll with this. I'm not afraid. All right, so I assume we need a little request.go, package request, and then we also need a request test.go and package. I would, you can typically do that one. There we go. That's also part of the request package. Okay, nice. Okay, so we're going to just keep it like that so we can reach for internal stuff. Install the testify package. Func, what's the test we're going to be doing? All right, I've added a simple test that doesn't test any application logic yet, but ensures you have testify and everything set up. All right, let's just go like that. So we'll go like this, bam, 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 bam. Do that bad boy, and then we can go like this. Go mod tidy. You don't have to do all that other stuff. LSP restart. You don't have to do that. You don't have to use go get anymore. You can just use go mod tidy. That's what I prefer to do. Little go mod tidy. You know what I mean? All right. We can run our test to make sure they all work, but I'm not going to run my test to see if they all work. Instead, I'm just going to assume that I'm right. You know what I mean? Bam. First try. didn't even test, just like my lack of test, didn't even test. So there we go. So parsing the request line. So we're gonna start with the request line. By the way, this is your request line, your start line. It's it's like it's the declaration for what's inside of the request, inside the HTTP message. Now, it's time to get to the best part of any project, the string parsing, which, by the way, I actually like string parsing. I personally find string parsing fun. Some people hate string parsing. By building on top of TCP, we already have code that handles plain text data. Now, we just need to take that plain text and turn it into structured data, ensuring that it follows the HTTP protocol. So here we go. Here's our example given stuff. Now, notice that this is actually an incorrect example. So, Lane, I'm going to have to report this. Here we go. I'm going to report something. Yes, I'm going to have to report an issue. Sir, your get example at the top does has a body, but it does not have a content length that reflects that it has a body. This is incorrect. Okay, this is incorrect. You have run afoul. Tips Fedora. Boom. Submit. Appreciate your feedback. Appreciate you, buddy. Should have known better. Idiot. Idiot. Thanks for your attention to this matter. Ding on the yeah, dude. I know. Classic maintainer. Well, the nice part is that Lane takes my shitty writing and turns it into nice writing. So he might have just accidentally pasted this incorrect, and he meant to have this as a post with all the other stuff. Like probably accidentally goofed the two up. But either way, doesn't really matter. We want our HTTP parser to return a struct that looks like this. Yes. Boom. So let's grab that bad boy. Let's grab that struct, and I'm going to add these two things to my harpoon, so I can go because that feels good. You know what I mean? No, that's not what I wanted. I wanted this thing right here. We want our structure to look like this. Okay. This way, our application logic, the server code, has a nicely structured HTTP data to work with. The goal is to take the server we've created in the last section and have it parse out the start line according to the RFC here. So you can go check the RFC if you're ever curious. I made sure I always linked out all the parts to the RFC that were relevant. So this is how you actually look at, like, say, the HTTP version. You can read this. It's actually a pretty simple way to read this data, right? HTTP version is an HTTP name, a slash, a digit, dot, digit. In other words, it's HTTP slash 1.1, right? So I tried to link out the RFC wherever I could. That was super relevant. And then also included like inline version, so it's really easy. It's a bit hairy to read, but I think you guys get that. So there you go. You can do this. So the assignment here, we are using test-driven development. Uncle Bob would be proud. On a real note, when it comes to black box RFCs like this, good tests help us move blazingly faster and avoid bugs. So this is where I actually think test-driven development is good, in the sense that there is a singular right answer here, which is the protocol. I read the protocol, I make the test from the protocol, I fulfill the test by implementing it. To me, this is a much easier way to do TDD, and this actually makes sense, right? This is where things are well defined. It's also a black box, and I like it, right? It's when it's not a black box that I don't like, right? Like I wouldn't do it for something I don't know. This is a well defined. All right, so here we go. So now we have this one. So here we go. Let me try grabbing that. That's not going to copy either, is it? I wonder what's going on with that. All right. Let's go like that. Let me just do that. So there we go. We have our request and our request line. Why did you put it that direction? That upsets me. That actually upsets me that you define. I know you can do that with Go, but I don't like that. Okay? I don't like that. Okay, so there we go. There's our requests. And then let's see. Don't forget to capitalize your exports. Yeah, I know. Don't forget. Yeah, I know. I hate that. Hey, it's still better than public static void main. Yeah, okay, first off, Lane. Okay, I haven't read this yet. This is something new Lane has added. First off, Lane, public static void main is actually, it's much different than a capitalized export, because first off, it's a static function that can be ran on a class object, and also this is the main entry point, okay? And this is the return type. You don't have to say the return type, okay? You don't do this for every function, Lane. Okay, don't be dogging on Java just because of one small little thing. Come on, dog. All right, we're going to stub out a new function right here. So this is beautiful. Let's stub it out. Okay, there we go. So let's stub that function out. All right, add the following test to this thing. Okay, I'm just going to, dude, how do I copy things? All right, and then let's go into here and, yeah. There we go. We're going to add the import. Let's add this import. All right, is there anything else? All right, let's just make sure I understand everything. So we're going to do a new request from reader, which should be this guy. Awesome. New request from reader. Let's do it. All right, we have, and that does strings, HTTP 1.1, host, localhost 42069. Good job, user agent, curl, accept, ***. So there you go. And then you can see the empty line right here, right? There's the empty header. right? Because remember, every header is separated by a registered nurse. So you can see the first /r/n, and then the second one is just right here. This is the empty one, right? Because there's nothing there. We now have an empty header that signifies the end of the headers. Awesome. So we'll have a complete request, and then we expect coming back out that, by the way, you're using assert as opposed to equal. Oh, interesting. I would have used require the whole time, because assert, if I'm not mistaken. Wait, which one is this one? Yeah. Does assert? How does assert work here? I forget if assert is okay. I can't remember if assert doesn't fail immediately. So me personally, I'm not an assert boy. I'm a require boy. A require fails, but it fails immediately. Assert, I believe, can keep on running and then only fails at specific spots, or fails once the whole test is done, which is like a little bit weird, right? The code looks magnificent. Well, thank you very much. So there we go. You can see I do a get. We do a slash, we do this. Awesome. Test a good request right here. We do another one. This should have get, it should have coffee, it should have 1.1. Okay, perfect. This last one should do this one. This should just be /coffee, HTTP 1.1. You'll notice that the start line right here is in fact a failure. Okay, good. We have ourselves a failure. And we should expect there's an error. All right, awesome. So I guess we get to kind of make up our own errors here. So I'm going to go like this. var, let's see, error, what are we going to call this thing? Bad start line, right? I don't know what to call that thing, right? Error F, bad start line. Why not? There we go. Perfect. Everyone's on board, right? I think that's how you do these things. All right. Beautiful. Is everyone ready for this bad boy? So we have our test. It's up and running. Okay, so now what do we need to do? We need to implement request from reader function to parse out the request line from the reader. Here's some things to keep in mind. For now, you can slurp the entire request into memory using IO read all. Okay, that makes it really easy. Create a parse request line function to do the parsing. Remember, new lines in HTTP are /r/n, not just /n. Technically, that's not necessarily true inside the RFC. If the first line is separated by a /n, you must assume that all following lines are separated by a /n, which is not necessarily like that great of an experience. And I think there's a lot of parsers that don't do that, and so it will automatically fail. But a part of the RFC is that you can actually use just /n, and so it's like a really inconsistent parser. Yeah, so don't worry, don't worry about that thing. Okay, that's one of those things that just use /r/n. If you don't use /r/n, there will be some like transit along the way that's still running some old library that doesn't accept that, and it'll just like your stuff will just fail, and you will have no idea why, and it'll be very confusing and very painful because you didn't realize that there's some node from 1999 and it's still parting like it's 1999, and boom, you're dead in the water, right? So we're gonna do all these things. So let's do. I'll get the function up for func parse request line. And what should we put? What should we pass into the request line? That's a great question. How do I want to do this? I will take in some right now. Let's just try byte for now, and it will return a request line, or it's going to return an error. How does that sound? That's a pretty reasonable interface, I'd say. All right, I'm happy. I'm happy with that interface. Okay, so interesting. Okay, so you're using string.split. I would use bytes.split, but I guess we can use string. We'll use just string. Right, we're not going to concern ourselves, dude. We don't have to concern ourselves with strings or with bytes. Ew. Verify that the method part only contains capital alphanumeric characters. Right. Verify that the HTTP version is 1.1. Yep. All right. Here are some additional references that might help, but don't overthink it. This step should be pretty straightforward. True. Add more test cases and request underscore test go to cover any edge cases you think you might be here. Yeah. Right. You think I'm going to do? You think I'm going to add tests? What are you, idiot, Lane? All right, so there's some things I don't like about the interface I made. Because if you think about this, I have request line. I should have the rest of the string that is remaining, and then the error. Does that make sense? Because that feels like a better interface, at least to me. I have not taken my own course or looked at my own course in about 6 months. So I've actually forgotten the way I originally did it. But in my head, it's easier to have something that can parse a request line, right? And just be like, okay, here you go. And then returns the rest of the string that it doesn't know about. So watch, I can go like something like this. This is what I mean by that. I can go var separator. Why not? I think I probably spelled that correctly. And if I didn't, If I didn't, then guess what? Don't care. Remember, registered nurse. There we go. And so I'll have this one. Index equals, let's see, let's go like this. Strings index. It's funny when I can't remember how I wrote this, and now it's like I get to rediscover how I wrote this. All right, there we go. So we have our index. If IDX equals -1, meaning we haven't first found our new line yet, we haven't been able to parse out our start line, then I'm just going to return nil, and then I'll return the string that we are using, and nil. There's no error, but there's nothing for me to return. We haven't done anything. Now, I guess if I were to write go in a better way, perhaps I could return an error being like incomplete start line, right? And then that way I know I'm sending back a very explicit message like, hey, it's an incomplete start line. But for the sake of this, I don't think I need to do that. All right, here we go. So we have the IDX, we have the separator. So now we have the official line, or we have the good part, the goods, right? We have our start line up, wrong language. You do not do that here. That is not how we do this. B up to the IDX, right? All right, and then rest of line. Rest of message. Rest of message should be B, IDX plus the length of the separator, right? Remember, we're skipping the separator. Don't include the /r/n. Your life will be miserable if you do that. Don't do it. Do not do it. I've made that mistake many of times. So I'm going to return rest of, I'm going to return, yeah, oh yeah, that's a good one, request line. There we go. We'll put in one of those. I will have rest of message, and I'll have nil down here. So we're gonna fill this out. So we have our start line. So now I'm gonna have parts, which by the way, again, I just want you guys to realize that I've been playing with Elixir. That's what you need to do to be able to parse out a start line in Elixir. I just want you to look at that for a second. That, my friends, let's do it. Go is more verbose. Go's simplicity sometimes bites you in the butt. And this is one of the places where it does bite you in the butts. All right, here we go. Parts, let's go like this. Strings dot split. And let's go start line. We'll have our start line, and I want to split it with a space, right? There we go. We have a beautiful little space right here. Fantastico. And so we should be able to get this bad boy out. And now I cannot remember from the RFC or not. I'm pretty sure the RFC allows one or more white spaces. Maybe here, let's see can we go back to the RFC? Where's the RFC? I know I had the RFC out here. Let's see, what does the RFC require? I just can't remember. Message parsing, I think we can, request line. Okay, yes, a single space. Okay, so you don't have to worry about multiple spaces. So if somebody provides you a space, that's a malformed message. You can see right there, singular space. Very, very easy. Very, very nice. Pattern matching is pretty nice. I'm even a Go fan. Yeah, I'm a Go fan. I love Go. I am someone who actually genuinely loves Go. I think Go is really, really great. If length of parts does not equal 3, meaning we don't have method, path, HTTP protocol, then we have ourselves a bit of a problem. So let's go right here, and so we can go like this. I like the word malformed. Let's go like this, malformed, and we'll call it request line because that's technically the better, that's like sometimes I call it like a start line, but a request line I believe is a better way to say that. Malformed request line. Wow, that is way too large, but here we are. I guess I can go rest of message. It doesn't really matter because I have a malformed request line. Right, there we go. Way too long. Oh man, I've gone full Java on this one. So that means I should be able to do the following. I should be able to do method is going to be parts 0. Right? Request target, that's right. I always call it a path. Request target would be parts 1, and HTTP version would be parts 2. But we need to do a bit of validation, right? We need to do a touch of validation. Now, there's different ways in which we could attempt to validate this. I could validate it within this parsing function, or I could validate it afterwards and have something that actually does a request line validation check. And so we can do something that's kind of fun. Let's just do it this way because maybe I haven't done it this way. This kind of sounds fun to do. I'll go like this, request line, and I go valid HTTP, and then we'll have a boolean right here, and I'll go like this, r.http version return, and we're just gonna have it strictly equal HTTP version 1.1. There is nothing else that it can do, right? Our request line equals this one, return RL, bam, bam. If RL dot valid, if not valid HTTP, then we're gonna return a nil, and then let's have a, we'll stick with the malformed, right? It's I can have a better error, unsupported, insupported, unsupported, insupported. HTTP version, right? Unsupported HTTP version, right? Boom, error, there we go. And then of course we can, it doesn't really matter what I return back. Error, unsupported, bam. All right, there we go. All right, so I think this is probably how I would do it. Okay, so remember, we're gonna keep things simple because we could do that. So I'll go like this, data, equals IO read all. Remember, there's this nice reader function. I believe you can do it. You're supposed to do an error, right? Right? Read all. Yeah. So if we have this one, I'm just going to return nil error. What is it? Is it errors dot? You do wrap, unwrap. Where's the wrap function? Where's the one that you can do a nice like little wrap on it? Is it? Do we just do format error f? Unable to read all. Unable to IO dot read all. And then do we do a W here? I always forget this part. I haven't played with errors in a little bit to have like the proper one. Is it errors join? Is it always errors join? I have always just done this, but I don't feel like that's very good. I don't feel like that's a good way to do it, and I've never liked it. Errors join. Okay, I wasn't sure if join is correct, if join is the way you want to do it or not. So then I would just paste in this one, and so that means I'd go format, error F, unable to read, IO read all, right? And then I could also do and then do that, and do that. There we go, right? Yeah, okay, that's fine with me. Once we have the data, I'll have the request line. We'll have rest data, and then I'll have, let's see, hold on. We'll go stir equals string data. We'll do that, right? Since we're working with strings, we'll keep it as strings, even though this is not, it's not really the way I would like to do that. It makes me feel a bit uncomfortable, to tell you the honest truth, just working with strings like this. And I don't know why. I think it's part of me is this thing where it's like, I cannot live a life in which I do things that like involve copying. It makes me really angry. Return RL error, right? Okay, this one does a request, so I'm gonna go request. There we go. And then what is in here? We have request line, and that's gonna be an RL. There we go. Oh, let me guess, it's not a pointer. Okay, copy it out. Perfect. Okay, so if I've done this all correctly, then we did this. Okay, there we go. Did a quick 70 lines of code. We're gonna go back to this one. And we have request from reader. We have all these ones. We have get 1.1, get one, all this one. And there we go. So now if we've done this all correct, we should just be able to take this thing and run this one and go. Damn it. Why didn't that work? I should have first tried it. Okay, I got a failure. Damn, I'm an idiot. I'm not even a programmer anymore. Oh, I didn't realize you wanted it like that. Okay. I didn't realize. I should have read the test. Okay, I should have read the test. Hey, I just wanted to do that whole like make it red, then make it green thing. You know what I mean? I was just doing the right thing here. Okay? I was just doing the right thing. That's all. Okay? I was just doing the right thing. All right, so let's go like this. Let's go HTTP parts equals parts2 strings dot split. Parts 2, also not one of those, but one of these. Yank that one. Bam, malformed one this. 2 HTTP parts. Okay, so if it's not a 2, we have an malformed request line. That seems good to me. Or HTTP parts 0 does not equal HTTP, right? Or I guess HTTP parts 1 does not equal 1.1, right? So now I can take out this whole valid HTTP part because I thought I was going to have that, which I'm not going to have that. So let's just take that out. Bada bing, bada boom. So there we go. We have all of those. So now all I have to do is go, instead of parts 2, I'm just going to go HTTP parts, obviously 1. And now, obviously, now that's first try. Okay, no, that's not a wrong one. Okay, hey, you know what? I'll say my fault. My fault. So what? Maybe I didn't read all the things. Maybe I didn't read all the things that I need to do. Okay, I obviously have a nil pointer dereferencing that I goofed up. Let's find out what happened here. I probably didn't read the test well. All right, there we go. So what's the ish bish? Okay, panic, request from reader, internal request 65. All right, we can do that. Let's go like that. 65 right here. Request line does this bad boy. I guess I don't really check for error, huh? So if the error does not equal nil, I should probably do this, huh? I'd like to say this is Go's fault, but it's not. It really isn't Go's fault. Where is the skill issue? All right, unfortunately, parsing code tends to be just one edge case after another. Yes, it really, truly is. I remember how I said TCP guarantees data to be in order. That's true, but I never said it would be complete. TCP, and by extension HTTP, is a streaming protocol, which means we receive data in chunks and should be able to parse it when it comes in. So instead of a full HTTP request, we might just get this. G. Then we need to be able to do this. G. It needs to be smart enough to know that it's not done yet and keep reading until it gets the full request line. True. Paste in this code. Okay. What is this? What is this? Oh, into our test. Oh, I wrote this. This was pretty clever, by the way. I wrote this. This is pretty clever. I'm pretty clever. Okay. I am pretty smart. Okay. I'm pretty smart. I wrote that guy. All right, update your test suite to use chunk reader instead. Okay, there we go. We're going to use chunk reader right there. Reader equals chunk reader. And what do we want here? We want the chunk reader. Okay, so we want to do it that way. Okay, I got that. Whoa. Did I go somewhere else? No, I didn't. Okay, so we want to go chunk reader this guy. I can do this here. I'm just going to copy and paste this bad boy. DI that one. Let's see, what do we got here? We got chunk reader. We're going to do the get right here. Then we're going to pass in this new reader. This chunk reader is actually really, really simple. A chunk reader simply is a struct that just will emit out a certain amount of data at a time. This if statement can be modularized using min. Really? Let's see what happens, boys. All right, so there we go. So this should be pretty easy. We're just going to read bytes 1 at a time or 3 at a time or some amount at a time so it's not obvious. And then now we need to update our parse line to return the number of bytes it consumed. Okay, that is also a very nice way to do this. If it can't find the /r/n, this is important. It should return 0 and no error. Okay, nice. So previous me, which I think did it more correct, is that this thing, instead of taking, see this, if it took in bytes, I probably would have done number, but since it takes in string, I return string. I think that's more correct, all right? I'm just saying, I think it's more correct, okay? I think I'm more correct here. Very Sigma stream, thank you very much. Good morning, chat. What are we building? HTTP. It's in the talk. Okay. All right, so we've gone through here. We're going to do a parse request line. This seems fantastic. Returns the number of bytes it's done. Add a new internal enum. I just use an int to your request struct to track the state of the parser. That's right. We now need to create a parser. So I'm going to go like this. Type parser state is just an int const. And we're going to go like this. Init, which is a parser state, equals init. And then we're going to have done. Oh, we can't have init, can we? Init. Oh, how do we do this? State init. State, what's it called? Read, or what is it? State done, right? Parser state equals done. There we go. Oh, we don't do these, do we? No commas. Init. Oh, it's an int. Yeah, that's right. We can just do that. You know, actually, I'm gonna go with string. I feel like I like strings better. You know what I mean? Because then I can read them. If there's an error, it just feels easier for me to read. You know what that means? You know what I'm talking about? You know what I'm talking about? I feel like I like that better. And I kind of want to make some changes because honestly, I want to consider more, so obviously we're going to have like a state parser and all this kind of stuff. I feel like it makes more sense. I'm curious how we want to do this. Implement a parse data method. It accepts the next slice of bytes that it reads and does all this. Yes. Okay. So I see how we're doing this. Let's see. Hold on, let me see this. I don't really like this transition. I feel like it's a touch confusing. Implement a new function, request parse data int error. It accepts the next slice of bytes that needs to be parsed into the request struct. It updates the state of the parser and it parse line field. Yes, it returns the number of bytes it consumed, meaning successfully parsed, and an error if it encountered one. Okay, cool. So let's start here. Okay, so this should be pretty easy. So what I'm going to do is I'm going to need to go up to this thing, and we're going to have a state, which is going to be a parser state, right? I'm also going to take this, and I'm going to delete that, and I'm going to put it up top. I have this thing where I just don't like, I like everything that's needed should be above. It's just like a me personal thing. It's just how I like to live my life. So that's my parser state. And so now let's go here, and we're going to take a request from reader. And how do we want to do this? What we're going to want to do is instead of doing this read all business, which is not necessarily the greatest way to do things, I'm going to go like this. I'm going to create a request, and this request is going to be this bad boy right here, right? There we go. A nice little pointer to a request. Fantastico. We have these things. And so when I create this, actually, let's go like this. Let's go func new request. And this thing should return out a request. And I'm going to go like this, return request. And I'm going to have state should be, what's it called? What do I call it? I call it state init. Right, there we go. Fantastic. I kind of like that. It doesn't make you feel a little bit better, right? It makes me feel a little bit better doing it this way. New request. There we go. So I have my new request. Everything looks good. We're ready to start rocking. And so now I want to create a for loop instead of reading everything at once, right? We want to simulate reading slowly over time. We don't know how long this thing is going to be. You'd never want to do, obviously, read all in practice because it could just hang. You know, you don't want it to just hang because you only need to read through the headers. The body parsing doesn't need to happen right away, right? You can send off a message, hey, I got a new request. It's to this path. It's a post. It has these headers. And then it's, you know, you're able to run. In fact, you don't even need to parse all the headers. That's why often you'll notice that some libraries, when you want the headers, you have to do some sort of async operation like an await in JavaScript. That's because after you read the first line, you already know what handler to call because you have the path and you have the verb. So if you have a post for /foo, and your first line already contains /foo, you can call that handler, and then it can await the headers while you're still waiting to parse. That's why there's all these like little speed up and tricks that you want to do, and this is why it's also really good not to. I mean, and this just is also just an insane way to do things, right? But it was good for our little initial reading, right? So I'm gonna go like this: data equals make bytes. Let's just go with 1024. I like nice powers of 2. It just makes me feel happy. I'll go like this: buff. Let's go. Buff, and let's also go n equals 0. This is kind of where I'm at. I'll call it buff index. We'll call it 0. I feel like this is the right way to go currently. Okay, we'll see what happens here. So now that we have that, we're going to go like this, request.parse. I'm going to parse out some stuff after I do a little bit of reading. So I'll go like this. I'll go reader.read. I'll read in the buff. Okay, I'll read in the buff, and I'll pass in the slice starting at buff index here. So I'm going to read starting right here. So obviously I start from 0 to 1024. I'm going to read out that data. In here I'm going to get n and error. I still don't know really what to do with errors right now, right? Do we pass back out the errors? Probably something we need to go to do. What to do here, question mark, right? If we get an error while reading, should we just pass through the error? You got to remember end of file is also an error. So it's like you probably should handle end of file. That means that the connection has been closed, right? So there's some things we got to kind of figure out here. So there we go. So we have this bad boy right here. So we've read out some data into the buff, which means that we have our new buff index goes all the way up to buff index plus n, so we have a little bit of a goofiness. So we actually want to be able to take the request and we want to be able to parse out our buff starting all the way up from here from buff index plus n, right? Do you see that? We want to parse all that out, get out all these answers, and then the output of parse should be something a little bit different. So let's go in here and let's go like this. Let's go func r is going to be a request, right? And we're going to go parse, which is going to take in some data, right? Which is going to be a byte. I like working with bytes. Bytes make me happy. And then I'll pass out an int and probably an error. That's probably what we want to do. How much of the buffer we parsed and our error. Does that sound pretty good? And then we'll have another funct called our request is done, which is going to be a boolean. Which I'll just call done because you don't need the boot is. What is this? C#? Get that line out of there. And I'll go like this: return r dot state equals state done. Right there we go. Pretty straightforward, right? So now we're building up our state machine to actually do parsing. Because before we just kind of raw dogged it. We just grabbed all the data at once, parsed the header line, said we parsed it correct, or not the header line, sorry, the start line, the request line. Everything was great, moved on from there, right? So now we're going to start actually doing more proper stuff going on here. So we're going to create a new request. We're going to make our buffer for reading. We're going to read out the buffer. Still don't know what to do with this error yet because we got to kind of figure out that thing. And then we're going to take this request. We're going to do that, and that'll be readn and error, right? So if we have an error, we should probably also return out an error, right? There's something there that's really important about that. And there we go. And so once we parse out this thing, this looks beautiful, right? And then we'll go like this, while not request done. There we go. We're just going to keep on reading while the request is not done. Pretty straightforward. Now, this readn, we obviously have to do something with that. That shouldn't be too hard. You can imagine that what we could do, I think an easy way to do this is that once that data has been consumed, we no longer need the data. So I theoretically should be able to do the following. I should be able to say, okay, buff index equals buff index, or it'd be plus equals n, right? So that's where the new buff index is. Here, well, in fact, we'll go like this. Here, we're going to rename index to length, right? It makes probably a little bit more sense to call it buff length. So that's our buff length. All right, so we're going to read our buff length. Now, whatever data we have read, we can go buff len minus equals read n, right? And then we can copy. Actually, let's not do that quite yet. We'll do that at the end. And we can copy. This takes a destination and a source to read from. We're going to take our buff as our destination, and our source, of course, is going to be starting at read n up into buff length. Now, there might be an error here. This is always one of those things that it gets a little bit tricksy. Whenever you're playing with slices, real easy to goof this up. But that should be, I'm going to take my destination, which is just my buffer, and I'm going to take from the offset of read n up until the length and move that all in. And I'm going to move that to the beginning. Then I'm going to adjust my buff length, and we're going to call it a day. Pretty straightforward, I'd say. Everybody understanding it? I think everyone should understand this. Pretty easy. So there we go. So now we have a nice reading mechanism. The reading mechanism is super simple. We don't care about the underlying, how it's parsing and all that. We just care about the reading. Reading bytes after bytes after bytes after bytes, keeping a buffer going like this. We also have this one problem, which if you haven't guessed, we have this whole problem where theoretically the buffer length could exceed the buffer we've allocated, and we need to make our buffer bigger. Not currently worried about that, but that's just a call out. Note, buffer could get overrun. A header that exceeds 1K would do that, right? Or really just, or the body, right? The body would also do that, right? So obviously, things you got to be a little bit careful about. All right, so there we go. We're going to drop that problem. And so now we have this thing. So we're going to just drop all of this. We're going to drop all of this. We're going to return request and nil. There we go. So now the parse needs to be more correct. So I'm going to go like this. I'm going to go switch, right, r.state, and we'll go like this. Case state init. If we're in state init, we'll do this. State done. We're going to return 0 or like nil, right? If we are done, we're done. That's that. Maybe. I'll go like this. Read equals 0. Read equals 0. There we go. And then we'll do a little for loop on top of this. This will make sense here in a second why we're doing this. And then I'll put that out here because I typically like that. Outer, and then do a little break outer. Right, there we go. That's typically how I prefer to program this, is I have a state machine that keeps on running. Because you can imagine you could also get a really large piece of data that contains several state transitions. So you want to keep looping. So it's like, oh, I can parse the start line. I can parse a header. I can keep parsing header. So I can parse all the way up into middle of the body. So you want to be able to do that in like a single for loop, but you also want to be able to return how much you've actually read. Okay, cool. So we're kind of getting places. So I'm kind of like doing things. That labeling gives me the ick. Oh, labeling gives me the ick for sure. But I also just hate returning from a deeply nested item. It's just a me personal coding technique that I found bites my ass a bunch. So there we go. So we're going to parse based on this data. And so if we're in state init, that means we need to be able to parse out the header. So I'm going to go like this. Let's go back into here. I'm going to change this to byte because I just prefer bytes, okay? This is how many bytes we've read from there. Let's go. So that means I can go like this. Bytes. There we go. We have a separator, which let's take the separator and let's go like this. There we go. So now we have that bad boy, which I'm going to go like this. We read 0 bytes, couldn't find anything, no errors, right? So if we have no separator, no /r/n, no registered nurse, we're not returning anything, no errors, it's just not simply there. All right, our start line is same like that. Our rest of message is that, which is good, which we don't actually even need to worry about that, right? Read equals this, right? That's how much we've read. So now we're going to take this little, this, and we can go bytes, and we can actually just take that bad boy, and I think we can do, does it have split? Does it have split and, okay, it does just have split, okay. Byte. There we go. So we have all the exact same stuff, right? Look at that. We have all the exact same stuff that we're just doing. We're just simply replacing things with bytes instead of strings, because remember, a string is a byte. Or a string is a byte array. It is the exact same thing. They're no different. All right, so this is where the only thing that becomes a little bit different, so I can just go like this just to make it easy. Remember, we're not concerned about performance on this. I can just string these ones out, right? By stringing those out, makes it really easy. Awesome. All right, so now we have these things, which is going to just simply be a string, string, string. There we go. That's correct. And then a read. That's how many bytes we've read. All right, so there we go. I've upgraded this request parse line from a string into a byte array. I prefer bytes. I think bytes just make more sense to think about when you're parsing stuff out. It just feels more correct, at least in my head. Okay, awesome. So now we do read 0. If we are in state init, I'm going to go like this. I'm going to go, what's our return format? Request line, that's right. So I'd go rl n equals parse request line, and then let's just pass in the data, right? The data starting at read, right? Because how much have we read? I don't know how much we've read. If we've read stuff, most fantastic. If we have an error, then we'll just simply go like this. I didn't read anything. There's an error. We don't care. It's wrong. Get the hell out of here. I never want to talk to you again. You're a loser. If we don't have that, we can go r dot request line equals rl, right? And then we need to do that whole copying business. And then we also need to go read plus equals n. Fantastic. If n equals 0, then we simply need to break outer, right? We need to get out of here. We haven't read anything. We're unable to move forward. You're going to have to keep on parsing for us, right? All right, everybody on the same page? If you're not on the same page, I'm sorry. We're moving fast. We got to get things done. So as you can see, we now parse the request line. If there's an error, we go, error. If n equals 0, we just simply break outer and return. If we have actually done this, we go right here, and then we need to go to the next state. So that means I need to go like this. I'm going to go like this, state.done, right? That's the next state. Now, I bet you there's a nicer way to actually, like, make this state transition. Right now, I'm doing it this way. I bet you we could come up with something that's better, right? You could have an array of states through, but we haven't quite done that, right? So I could also do something like this as well that is kind of interesting. I could do something like this and have a state.error, right? I'm not sure if this is any good. I'd have to actually think through this, but I think that it's going to be fun to do this anyways, just because I want to kind of do this just to see how it feels, right? So I can go state equals state.error. That is incorrectly spelled. I've never been afraid of bad spelling. Never been afraid. State.error. Return, what's it called? 0, let's see, errors. Should I have this defined? By the way, for us Go people, do you like to have your errors defined like this? Or do you actually, you know what, me personally, I don't like how many, it makes me feel like I'm yelling at myself. So I'm just gonna like this error malformed request line. I feel like that just makes me happier, honestly. Error unsupported HTTP version. The hard part is that now that I'm getting into Elixir, my brain is like elixiring really hard all the time. And I'm finding myself like just changing all sorts of things that I normally wouldn't do. Request in error state. Request all in error state. There we go. I'm currently defining it like that, but I feel like I shouldn't do that. I feel like there we go. So if you try to do anything, if I'm in an error state, I just say, hey, you can't do anything. There you go. So all right, I'm happy with this one. Super fantastic. We'll yank this one, and we'll also have error, which will be state.error, and that way my little for loop can have and not request.error, right? I guess, or I could do it the other way around, or r.state equals state.error. Yeah, that actually might feel better because it is technically done. There's no progressing. Who cares? We're not too worried about things yet. All right, so this looks nice. We have all this beautiful stuff. We're all feeling good about what we've done thus far. I have my error state, I have my state machine, I have my initial state, which is the parse lining. If we encounter something in which we can't finish the request, we should be able to do that. And we have our done, we have our loop that keeps on running, and then ultimately we'll return this. So if I've done this all correctly, my test should continue to pass. Now, here's the deal. I have not actually attempted to try this out because, bros, we are just first trying every try. So here we go, first try, and we first try, and we nailed it. Nothing. Come on, let's go. Okay, here we go. Okay, we are first tryers. Let's keep on going then, huh? Congratulations. Parsing data as it comes into the program is much harder than parsing an entire message. Yes, I think we can all agree to that. Parsing things byte by byte is actually a very hard practice, and it's a really good way to tell if you're actually doing something well by us doing it like this, right? We are reading it one byte at a time. We get G, E, T, space, /, C, O, F, F. And so we're just running through this loop over and over and over and over again, which actually makes it really, really nice to do. So I actually don't know how I did. So look, we're about to look at my code from before. This is kind of crazy. Let's see how I did it. Okay, so we have our CRLF. That would be our that thing. Our buffer size 8. That's how, I'm curious. So we actually go request from reader. We're going to do this one. We do a little state. We have a request state initialized. So I did it a little bit different. I did a new request this time. We did this. Our buffer size here is teensy tiny. If you look at our test, we also recall that we added some test cases where only 1 or 2 bytes are read at a time. We want to test at these small buffer sizes to ensure our parser can handle the edge cases where even something as small as a request line is split into multiple reads. Yes. That said, in production, it's probably a ridiculous buffer size. You want to probably optimize for performance, and my guess you'd likely start with the buffer size way larger, right? Or something. I don't know. I just work here, right? I have no idea how big of a buffer size you'd want to start with because you have a balance between allocation and processing of the stuff. But I'm sure you could kind of figure out a nice little line so you don't have to reallocate. You don't have to do any sort of additional stuff. You'd have to do some testing yourself, but I'm sure there's a number that just makes sense. And I'm sure somebody already has a number that makes sense. They're like, hey, if you do this, this is the optimal HTTP GET request. If you are like some sort of node that just simply is a relay that forwards things on a proxy, you probably have a different buffer size than if you're doing an application, right? All of this stuff is testing. Okay, next I want to point out there's a difference between reading and parsing. True and true. Nice, look at this. I have this little bad boy right here. So let's see, how close is this? Oh, nice, we do this little bad boy right here. Nice, ooh, I did, okay, so this is what I was actually curious about. So I have in here, errors is end of file, then we say, hey, state is done, that's it, which is kind of true, but I'm not sure if that is even true within the context of this, right? If we do a read and there's an error, well, how do we handle when a file has been closed, right? Because HTTP works with a request and response. We should effectively never run into an end of file like that. I feel like that there's a fundamental break there if we hit an end of file. So I'd actually like to rethink about that a little bit. This can be confusing, but it's important to understand the difference. When we read, all we're doing is moving data from the reader, which in this case of HTTP is a network connection, but it could be a file as well. Our code is agnostic, programmer's second favorite term of the universe, into our program. When we parse, we are taking the data and interpreting it, moving it from a byte into request line struct. Once it's parsed, we can discard it from the buffer to save memory. Right. What's the difference between reading and parsing? Reading moves raw bytes into memory, parsing interprets them. Boom, that is correct. All right, state machine. A state machine is a fancy word for a system that can be in one of many different states. For example, this function is not a state machine. Correct. Because it doesn't have any internal state. It just takes 2 numbers and returns their sum. But this function is a state machine. There we go. Yes, in some sense, this is an extremely simple state machine. The machine is very one-dimensional. It just simply has a bit of state into it, and we mutate it through a function call. But it has internal state count, and each time we call add, it changes the state of the counter or of the counter struct. It's not a pure function, it's a stateful function. We built a state machine. The combination of request from reader and request parse functions create our state machine. We keep track of several pieces of state. We also actually have where are we in the state machine that really gives it that state flow, or where people traditionally think of a state machine. They think of a state machine having several steps that we read through. How much data we've read from our reader, how much data have we parsed into the buffer, the current state, yeah, loaded. It's a loaded term here of the parser, done. All right, which describes the state machine? Any function that modifies a variable, a system that changes based on its internal state. That's what I would personally choose. There we go. Got it, first try. All right, connect the parsing. We've got all the tests passing now. Now it's time to actually use our parser in our TCP listener. By the end of this lesson, you'll have a TCP listener that can parse a request line from the curl request. Right? Hey, that would be cool, right? That means we're literally using a real library to test things. Typically, I would do a state machine as something that has states that it has to move through. It should be able to be represented by a push-down automata, right? But to be completely fair, I didn't write this part. He wrote this course, and the Wags Lane technically wrote this state machine excerpt. So if you're going to blame anybody, we're going to blame it on Common W Lane. Okay, let's everybody rare L lane really quickly and then put this in the YouTube video. All right. Rare L lane. Yeah, there we go. Yeah, lots of L's. I can handle them. I mean, his name literally starts with an L. Bro can handle the L's. Believe it or not, this step is super easy. All right, we already did the hard parts. Delete your get channeled lines function. We're working with HTTP now, not just new lines. Similarly, delete the resulting logic that prints the text coming back across its channel. Instead, call request from reader, assuming it's successful, and print out the request line in this format with dynamic data, of course. Okay, we can do that. Run your TCP program again from the root and redirect it. Yep, we can do that. Okay, so let's go like this. I don't have this. Git init, git add this, git commit, blah, blah, blah. I could have done Batman, but we didn't do Batman. There we go. So I'm going to go like this. TCP listener main.go. So let's just take this bad boy. Let's delete that bad boy out. Take a listener. We're going to do this. We're going to get a new listener. We're going to get a new connection. And we're going to go like this. Request equals request and an error. We'll call it R in this. And then we're going to go like this. Request, right? Because we have a module called request. So request from reader, pass in the con. Dude, guys, we've owned the cons. We've done it. Right? We've done it. We've owned the cons. And then we're going to go like this. Format print L or F. How did I do this? How did he want this bad boy? All right. Let's go like this. So I'm going to want to go like this. Log or format print F. Yeah, I like that. Let's go $. Yes. I like that. And then let's go %s / new line / I forgot to put those / new lines. Target %s / new line. And then version is %s / new line. There we go. And we should be able to go like this. R dot method. R dot request line target. R dot request line HTTP version. There we go. Format that. There we go. We've now done it. How do you guys feel? Pretty good? I feel pretty happy about that. Nice. Nice. Okay, now we need to submit this. First try. All right, let's get into the next hard part. Honestly, so the next part's gonna be a lot more difficult. It's actually why I wanted to do this course specifically for Lane, because I feel like this is a great way to go from like a junior engineer into a mid-level engineer, is just making these understandings. Because when you understand really how HTTP works, it doesn't matter if it's HTTP 1.1, 2, or 3, you understand it at a more fundamental level. So when you see something like, oh, why do I await the headers? You understand internally its implementation. You understand the request response model. You even can naturally understand the WebSockets protocol. It'd be fun to do a WebSockets protocol one. Maybe we'll do a WebSockets protocol one in Elixir or something like that. That'd be a lot of fun. Are you implementing the full HTTP protocol or just partial? At the end of the day, it's two different things, right? There's parsing of the protocol and the server implementation of the protocol, right? So those are two very different things. So we're going to implement the full parsing. It won't be the full server implementation, right? Because there's like a lot of edge cases. Like, how do you respond to a thread that panics in a server? Well, that requires a lot of, now you have to do like a recover. Yeah, there's 1,000 edge cases. It becomes deeply unfun. But parsing of the protocol is many, many less edge cases. Still a lot of edge cases, but many less edge cases. When we say headers, it's important to note that the RFC doesn't call them that. The RFC uses the term field line, but it's basically the same thing. The field syntax right here. Here, I inlined the field syntax for you. If you want to go read about it, go check it out. That's right here, right? So if you go right here, you can see the field line parsing. It's actually pretty straightforward stuff. So if we were to take this, we could take this. This guy is just simply a field line equals a field name, OWS. So what is OWS? I believe that means unlimited amounts of white space, right? Some amount, an optional leading white space, right? So some amount of white space. So this can be as long as it wants to be or none. It's 0 or more white space. Notice that there is no white space right here. A field name does not have optional white space. A field value has optional white space on both before the field value and after the field value, which is kind of annoying, but whatever. It is just what it is. It does not matter, right? One important point to note that there can be an unlimited amount of white space before and after a field value header. However, while parsing a field name, there must be no space betwixt the colon and the field name. In other words, these are valid. That's not valid. All right, good. Okay. Create a new package in our internal directory called headers. I made it a separate package because we'll use the header package for both parsing the request and for sending responses. This is a stylistic choice rather than a design capital D choice. Yeah, this is just It's just simple stuff. That's all I'm doing. I'm not trying to make things too hard. I think I'd write this a little bit different if I was trying to actually ship something, right? Headers.go, and I think everyone can understand that. We'll have headers test.go, package headers. There we go. All right, here's our type header. It's going to be a type header is this guy. All right, that seems pretty reasonable. I like that. Whoopsie daisies. Let's go to headers, and let's go to headers test. There we go. Bum. All right, let's put in that bad boy. All right, awesome. Create a new method for parsing a header in, let's see, a request into the headers. There we go. We're going to parse this bad boy right here. Func, that by, did we miss func? There we go. Here, Lane, I'll give you a little piece of feedback. The header parse definition is missing func. Not that it's like a big deal. That's pretty easy to, Let's keep on going here. Okay, so we have this bad boy. So create a headers.go. We're going to have to do a bit of a parsing. Create a new headers test go with the header package. And we're going to do this one right here. Can I not copy this one? I feel like it's not copying for me. So we're going to go like this. All right, I forget, is it testing T? Is it a pointer? I can't remember if it's a pointer or not. All right, there we go. New headers. Func, new headers, header. I don't think we need to do that because it's technically just a map. I don't think you need to return it as a pointer. That's one of those things I always forget. Fantastic. We got ourselves a bit of a test right here, so let's just make sure that our test is looking good. Okay, we got new headers. We need to have a require coming in from here. Awesome. We have a cert coming in from here. Again, I don't think I'd use the difference between the two, but I don't think that's really all that interesting. There we go. Headers.parse done. All right, so there we go. What do we got here? 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 All right, we're going to create this new thing right here where we're going to parse out these headers. Okay, fantastic. Update your parse method to pass in a single test. Let's see. Method to pass this single test. It should mutate the headers by adding new parse key value pairs and return n, the number of bytes it consumed. Done. Whether or not it finished parsing the headers, and error if it accounted an error. Look for CRLFs. If it does not find one, assume you haven't been given enough data. Consume your data. Yep. I'm sure there's like some parsing that you have to be a little bit careful about with headers that I haven't thought about, but whatever. Right now, we're going to do this right here. All right, so I'm going to have this one const. I think you have to do var when it comes. No, maybe you can do const. I can't remember. CR registered nurse, right? /n/ there we go. Right? And I'm also going to do it on byte because I want to use it as a byte, right? Okay, this is where we have to do a var, right? There we go. All right, we're going to return a new map string. There we go. We have a new map. There we go. It's just a headers, though. Fantastic. Now we're going to parse this one. This one should be pretty easy. We're going to get data coming in, and we are going to go like this. For red equals 0. Okay, we're just going to do another parsing, right? We've already parsed once. We're just parsing again. We've done this. We've seen this. We know what we're doing. It should be pretty easy. Now remember, do you remember what field lines look like? Field lines look like the following. We have a field name, we have a colon, we have optional space, we have field value, optional white space, and then a registered nurse. And then we stop, we're done parsing headers when we encounter the empty field line or a /r/n without any content in betwixt it. Okay. All right, there we go. So we're going to do this one. We're going to parse this bad boy out. And so how are we going to do this? It should be pretty straightforward. I'm going to go like this. IDX. Yes. Let's go like this. Let's go index. No, we don't need to do index byte. We're just going to do index. We're going to go data, and then we're going to pass in our registered nurse. If IDX equals -1, well, guess what? We're going to return. We're gonna break, right? We don't want to do anything like that. We're gonna return n. Here, let's do done as a boolean. Why not? Makes me happy, right? Don't you just love booleans? The new booleans. All right, there we go. Wait. Oh shoot! Hold on. I realize that I don't want this. That's called the naked return. I do not do naked returns. So this should be pretty easy. So here we go. We're going to do all this. So I'm not even going to read what it tells me to do because I'm pretty sure I already know what to do. So we're going to read out this one. If we run into a registered nurse, then we know. So now I'll go like this. If IDX equals 0, that means we have hit the empty header, right? This is the ending. So now all we need to do is we need to go like this. Done equals true. And we need the break, right? We are done. We've read everything we need to read. Okay, the end. Else, let's go like this. Let's take this bad boy out, and we need to grab out the header in right here. So let's go up here and let's have a func, and I'm going to call this parse header, which is going to be a line, a field line, a field line. That's going to be a set of bytes. So we already know that this is a field line. It should either work or it should not. So that means I'm going to return a key, I'm going to return a value, or I'm going to return an error, right? Easy peasy, pumpkin seedsy. This should not be hard. I'm going to go like this, parts equals bytes dot split. There we go, and I'll go field line, and I'm going to split it with the colon. And we're going to go byte, whoopsies. We're going to put that one in there, and we're going to do this, and we're going to do this, and we're going to have this nice little parts, and let's go like this. If parts, length of parts does not equal 2, if, ooh, actually, no, I need to do a split end, don't I? And we're going to just do 2, right? Wait, hold on, what is split? Let's see, well, I forget, what does let's see. Splits it into 2 sub-slices, separated by a separator, right? So if n, let's see, at most n sub-slices. The last sub-slice will be unsplit remainder, right? Okay, so that means 2 means 2 sub-slices, right? Because you could imagine your field value, I believe, can have a colon in it. And so if your field value can have a colon, what ID am I using? A neovim, baby. If I have a colon in my field value, I don't want to have multiple splits. Right? So there we go. If it does not equal 2, we have ourselves a bit of an error, right? So we would have bam, bam, error, right? The error would be format errors. Let's see, malformed header. There we go. Bam. So there we go. If we don't have those 2 parts, we do that. Else, let's parse out these 2 bad boys. That means we have our name equals parts 0, and we have our value equals parts 1. We're going to want to take this one, and we're going to want to go like this. Bytes. Do we have trim? Do we have trim space? Trim space returns a subslice of S by trimming off all the leading and trailing white space. Let's go. Let's go. Great function. Good function. Hey, good function. Let's go. Good function. Good function. Everybody clap for the function. Clap for the function. Let's go. Good function. Split n always returns 2 subslices. Won't lane parts always be 2, thus never return an error? No, because it can return a 1, right? Split n is... splits this thing separated by space and return blah 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 blah. Returns at most n subslices. So it could return subslice of 1, right? Little bit of an issue, right? We don't want 1, we want 2. I just couldn't remember if the n refers to how many times does it split or how many subslices it is. Because if it's how many times it's split, then I do 1, but if it's how many subslices, I do 2, right? Classic off by 1. All right, there we go. We got the name, we got the value. So now I believe I need to do a little bit of sub-checking in here, right? So I need to go like this. If bytes DAS has a suffix, let's go like this, name. So if I have at least a singular white space, I'm sure there's like probably a better and more sophisticated way to do this white space checking, because, you know, technically it doesn't have to be that kind of white space. How would I check to see is white space? Bytes, is there like a white space? How do I check for white space? That's actually something I don't know. Is there a white space checking function? That I don't even know. Because I think a more complete answer would be that I have to check, because you could imagine that I could have localhost, and then I could have, well, I guess if I had a /r/n, then it would break. My parsing would break. Yeah, we're just going to keep it as space. We'll just keep it as space. I think that's fine for this one. There we go. So there we go. If I have suffix, if the suffix contains 1 empty space, guess what? You had optional space that should not be contained in there. You have broken our contract, and I feel offended, okay? That is not good. You have hurt my feelings. So if I have this suffix, then I'm going to return out 7 up, 7 down, paste that in. Malformed header is actually good. I'll go like this, malformed field name. Okay, malformed field line. Look at that, I'm even using the proper term. All right, there we go. So we have suffix. If we have that one, we have our spaces. We should never have our spaces, else we are going to return name, value, nil. All right, there we go. Do that one, and we'll string that. There we go. Perfect. So this looks good. So we have our value, that's trimmed space. We have our name that has that one. Then we return these 2. And now we're going to go like this. We have these bad boys. And so then after that, I'm going to take this and I'm going to go like this. Name, value, equals parse, just a singular header. And that's going to be data up to IDX. There we go. We have that bad boy. And if I've done this all correctly, which I think I've read right there. Yep. Let's go like this. Read plus, let's see, plus equals n plus 2. 2, because obviously 2 being the length of the registered nurse, if we're going to be super specific about that. Here, if we have an error, we will obviously return a, how do I do errors here? Bool error. I'll just like this, false error. Else, we'll go into here. What is n? N, oh, I don't use n, do I? I use IDX. There we go. So we'll do those 2 things, and then I'm going to go like this. Now, when we do headers, now here's the interesting thing, because this already, a map is already a pointer, correct? So that means I should be able to go like this. I should just be able to go name equals value. This is where the named stuff I'm always a bit confused by, like what's the rules on that? There we go. Okay, perfect. So this should parse out as many headers as possible. And if we hit the empty one, it should return that as true. So that actually looks pretty good. I'm actually pretty happy with that one. It should fill up it should fill everything up. So if I go into here, let's test our header. Our header goes like this. New host, localhost, this. Okay, perfect. So this is a great test, by the way. Notice that there's a colon and then a second colon. So if I've done the incorrect split n, this should obviously happen. I should be able to see this one. Awesome. I do think that it would be important to have something like this, where we do something like header missing a key, right? It should return. I forget. Okay, this is something you may have to remind me of. When you have a map that's a string and go, it returns out the 0 value for the item in the second location or in the value location. So a 0 item for a string is an empty string, right? Pretty sure I'm like 99% correct on that one. It's one of those ones where if I'm going to first try this, I would like to first try this properly. You know what I mean? I'd like to first try this one properly. All right, there we go. So this should result in an error, right? There we go. We have an error. Let's also, I feel like this is a bit of a cheating an example. You know what I mean? So let's also have foo-foo, and that should have bar, right? Let's at least get 2. At least let's parse out 2 things, right? Bar. Ooh, can you hear that lightning? Foo-foo, right? Okay. Now, personally, I do not like accessing headers like this. I kind of feel like there's something wrong with accessing headers like this. I kind of feel like you should have a headers get and a headers set. I don't really like exposing the underlying implementation of a header as just a map string. I think I'd rather wrap it. It's one of those things where I don't like, typically I don't like exposing underlying implementation just in case I change my mind how I want things stored, and then I don't get like totally effed out of my mind, right? You know what I'm talking about? You know what I'm talking about, baby boys? Right? Because if you're super concerned about speed, and you're always receiving, say, less than 10 headers or 20 headers or even 30 headers, you could use an array and do an index search. It's just better than a map, right? It's one of those things where it's nice to have wrapped behavior. It's not even a strategy pattern. It's not OOPing. It's just that you have to be smart with how you do things, right? And this is just simply being like, hey, you don't really want to expose that it's just a map, because maybe there's things you want to do to it. Maybe you want to be able to have extra behavior on top. I don't know. It's one of those things where I'd have to think about that. Ooh, that is loud. If I lose my internet connection, I'm sorry, everybody. I'm going to continue to keep on recording if my internet goes down. And I'm going to keep on going through the course. I just like to do this live. Okay. So I believe I've done everything that I need to do. Add more test cases. I've already done that. Single valid header with extra white space. Oh yeah, we do want a little bit of white space. Did we test this one? Here, we'll go like that. There we go. So if I've done this correctly, that should pass. All right, here we go. Invalid spacing header, we already have that. I have this bad boy, and now, of course, I'm going to run it. I know what I did wrong. I technically did not first try this one. I'm such a dummy. Right. Wow, that's really loud. I forgot to do that. Okay, well, look at that. So even though I got it wrong, here we go. All right, so what are we doing wrong here? Let's go like this. Go, test. Bam. All right, what's your problem? What's your actual problem here? Expected this one, actually got that one. Okay, so that's wrong. How did I get that wrong? Let's look at this for a second, because I must have done something wrong here, because why am I getting all the way to here, right? Why am I, like, 2 past makes me feel like I definitely did something really obvious, and I have yet to figure out what I did wrong. Okay, so what do you do here? We're going to read up until a registered nurse. That should be the beginning of this all. We're going to read up to the index, but not including the index. Okay, so yes, I think I see the problem. I think it's pretty obvious here. Let's go like this. Let's start with where we've read up to our index. Okay, I think that's better. And then we do all that. There we go. So does that fix our problem? All right. Malformed header line. Okay, cool. Where did we get this one at? We got this one at line 15. Line 15 should be right here. And that should be this one right here, which is like, are you sure? What's going on here? Let's go like this. I'm going to go like this. Format, print F header that we're about to parse. I'm going to do a little one of these. I'll do 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 one of these. And then I'll string up that data.read IDX. There we go. That should probably tell me everything I need to know. Okay, so that looks really good. I like that. That's a very beautiful thing we have right there. This one, why is that? Why? ¿Por qué and Maria? All right, so obviously, what have I done wrong here? Right? I slice out the data from read to IDX. I get out of my name and value. Then I update my read by IDX and length. That seems like generally correct. I'm a little bit surprised about that, so maybe I'm just, again, maybe we're dumb here. Parsing header. Let's find out what we got here. This is the part that goes to show that parsing is hard, especially in a language like this. Every single time now, dude, I've become such an Elixir Andy where it's just like, oh yeah, I see this one. It's way easier to do it this way. This is just way easier. You know what I'm talking about? Like, this is way better. You know what I'm talking about? You know, hey, baby. Like, if I just use Elixir, it'd be so easy. Actually, I don't even know if it'd be easy in Elixir, and I'd probably be making all the same mistakes. I just like to pretend like I'm actually smart. You know what I mean? You know what I mean? Yeah, I think you guys know. Okay, so I've obviously done something wrong here. What have I done? Oh my gosh, it's so obvious. It's so obvious. Oh my gosh. It's so obvious. Do you guys see what I did wrong? Who here sees what I did wrong? Anyone see what I did wrong? I do. I see two things I did wrong. I believe I have a +2. Right? Do I have a +2 in here? No, I don't have a +2. That's fine. I don't have to worry about that. Right here. Okay? Right? We're not slicing down the header, shifting back to 0. We're moving it through. So when I have an index of 25, I've misread it like a dum-dum, and this should be better. Okay, well, that's still incorrect. I don't know what's actually happening here. I expected 23, got this. Okay, well, what did I do wrong here? Okay, that's line... All right, that's line 20. Oh, yeah, okay, oh. Well, that's because I hard-coded it to be something different. Okay, that's fine. That's fine. Here. I should technically return a 50. I should be returning a 52, right? I know what I did wrong there as well. I know what I did wrong is there as well, because when I do this, it should still fail. Yep, that makes sense. That's because when I do done is true, I got to also remember that I have to remove out that thing. So red plus equals length of the registered nurse, right? We have to slightly move it forward. Does that make sense? My bad, because the empty header still has something we're reading. There we go. Should be false. Okay, good. Now we're on to header 21. Done equals this. Wait, what's the example they give? What? No, that's incorrect. Lane, that's incorrect. 2/r/ns, 2 registered nurses is a finish. 2 contiguous registered nurses is correct. Lane. Gosh dang it, Lane. Right? Absolute cinema. Yeah, I'm the correct one, unless if there's something I'm missing. Let's see. Look for a Sierra. Let's see. If it doesn't find one, assume you haven't been given enough data. Yep. If you do find one, but it's at the start of the data, you found the end of the header, so return the proper values immediately. Did you see that? Return the proper values immediately? Yeah, you're the wrong one, Lane. You're the wrong one. Feedback. Feedback time. Quickly, feedback. Excuse me? Did you hear the thunder? The thunder of you getting the test wrong! Exclamation point. If you find 2, read them and weep. 2 registered nurses in a row, the function should return done. And your little test does not. How does it feel? Submit. Let's see, because last time I did like an LLM response, I'm actually curious. Thank you for the report. It seems you may have a mistake. You can get help by talking. Oh, yeah, no. First off, I don't have a mistake. You have a mistake. Tough guy. Damn, Prime. Prime is hurt. I know, I'm hurt. Okay, so it should be assert true. Done. Assert. This one should be false because there's an error here. There's an error here. Truing. There we go. Nailed it. Nailed it. Dude, we're header parsing, boys. All right. Not a first try. That's a fail. That's a fail. I'll accept that fail. Hey, guys, that's on me. Constraints. We've got our header parsing mostly working, but we're actually not being as strict as we would be to match the RFC. Let's fix that. Case insensitivity. Ever wonder why there's usually a get method on a header object to get the header values? This is why I knew internally I needed to get in a set method. I just couldn't remember why. Of course, case insensitivity, I'm an idiot. It's because the darned keys, not necessarily values, are case insensitive. If you use a hash map directly, you'll have to account for content length and content length and content length in SpongeBob case. So here we go. Also, there's only valid characters. That right? It has to be a token, and a token has a certain set of what is considered like valid tokens. So here's what a valid token should be. There we go. Digits and then special characters, and at least a length of 1. There we go. That is what a token should be. There we go. My bad. Should be easy. A content length. So let's go like this. I'm gonna turn this into a struct, and I'm gonna have headers underneath because that's just the way I would prefer it. To tell you the truth, this is how I would want to do this. I'd put it like this, and then I'd go headers, right? And then I'd do that and do one of those, and then I'd go like this. Let's take this guy. Let's take that. Let's put him up here because he is going to be before the header stuff. Let's move this thing down, and then let's put him right here because honestly that feels a little bit better. And then we have this header.parse business, and we also have func h headers, and we're going to need the, since that thing was a map, we didn't want to have to do that. Now we do have to do that. We have get name string, which is going to return out a string. And so we're going to go like, so this is interesting. Yeah, we'll do that. We'll keep it like that. Return h.headers.strings.to lower name. There we go. We always do that. Func.h.headers set name value string. We're going to do that bad boy. I'm going to yank that one, put it in here, go here, go here, go here, bada bam, bada bam. Easy peasy, pumpkin seedsy. Do we return an empty string if the header is not present? Yes, that's because it's a 0 value. Remember, the 0 value of a string is an empty string, not a nil. Take it or leave it. I'm not saying it's good. It just is what it is. You know what I mean? Set. Not saying it's fantastic, not saying it's horrible. It just is what the thing is. All right, there we go. So that means I should be able to jump into here, and I should be able to go like this, and I should be able to do a little get, and then do one of these, and go like this. There we go. That seems nice. Get. There we go. Beautiful, 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 beautiful. So if I've done everything correctly, I should be able to have both a get and a set. Fantastic. And then I also need to validate these tokens, right? Is the name actually within the valid set of characters? Because you have to be within the valid set of characters. And I also need to add a little extra test that tests to make sure that these things are valid characters. Here we go. So I'm going to grab all of these guys. So now I can't remember. I know there's probably a really great way to test for this. Is valid token, right? Let's see. Is token, right? So I should be able to go like stir string, right? So I have to go check for these ones. So is token, so I can take this guy, and this thing will expect it to be a length of 1. So this is where I was at. I was gonna switch this one and go, oh yeah, look at that bad boy. Look at that bad boy. Oh yeah, that's good. Actually that's return actually hold on. It is whoa, it's found equals false. Found equals true, and then let's go like this. Super. This is a nice. This is one nice thing about Super Maven is this thing. There we go. True. Can I also go like this? Can you go a? Can I do that? I can't remember if that's allowed in Golang. I thought there was a way to do this. Is it that? Isn't there a way to do this? Am I crazy in Golang? Isn't there a way to do that? Okay. Okay. Really? There's no way to do that? I just feel like it has to be allowed to do that. Is this just me being I swear there was a way. Dude, I somehow just don't. I feel like I just don't want to believe you. With the regex, you can. You know I don't use regeces, right? I'm not a regex guy. I'm just not a regex boy. Regexes make me feel angry. Okay. There we go. If not found, I'm return false, right? Boolean. There we go. Yay. Can you do that with the case? Okay, so if that's the case, You can do this, case. You can do that? Okay. By the way, I'm using what some people would refer to as the devil's lettuce of programming. Oh, you can't do that, can you? I actually have to do them all, right? I can't. Okay, you're right. Found equals true, right? I can't fall through. I can't fall through because then it won't match the rest of the stuff. Okay, my bad. Found equals true, right? There we go. Look at that nice big... You know, there's probably nicer ways to do this in other languages. This just ain't that language. You know what I'm talking about? Okay. Okay, I feel like I've been lied to. Okay, I've been lied to. Someone told me this was true, and now I've been lied to. Okay, I am not happy with my life. Okay, I'm not happy with my life. We gotta stop this. We gotta stop this right now. All right, there we go. Beautiful, there we go. I like it. Okay, so if we parse header, we do all these things, and so then when we parse it, we have all this thing, and we're gonna go like this. Now, I forget token. Does token apply to both field name and field value? I cannot remember that. Field name is a token, correct. Field names, okay, they can only be tokens, which are defined in 6.11. So I gotta go like this. If name is token, name. If, oh my gosh. If not is token, name. Wait. Oh, you're right. It does return back. I can just go like this, right? It's all the same thing, right? There you go. There's your little byte array. We got this beautiful thing right here. So if I hit this nice little token right here, then I'll go like this. If it's not a token, let's return 0, false, and the error would be simple. Okay, let's do an inline error. I feel like I like inline errors better for this one. Malformed header name. There we go. There we go. So if it's not a token, we return that. Beautiful. So we're gonna read through this. We're gonna do that. We're gonna parse the header. We're gonna validate that it's a token. Bada bing, bada boom. Now the thing I don't remember is update your parse method. Add a test case right here. All right, let's do this again, and let's go like this. Beautiful.